morning, good afternoon. So thank you to be with us today. So my name is Elie Abramo. I'm the CEO of Coinvesting Capital. So this nice office where we are today. And I will talk about Coinvesting Capital and what we are doing. Coinvesting Capital, it's an asset manager registered in the IFC. So we own a license 4 and license 3C. So the purpose of Coinvesting Capital is to manage assets for private clients and also to manage funds. And within the group Coinvesting, we have several verticals. So the first one, it's AI. So the group is tech oriented. So we have a strong tech DNA, and we will manage several funds. So the first one will be AI fund. The second one will be based on gold and commodities. We have an office in the MCC in Dubai, so Commodity Center, and we will manage gold and commodities fund. We have also a fund tech and fintech, of course, with Coinvesting Capital, which is the financial arm of the group, and Coinvesting Group with the tech arm of the group. We will launch a fintech fund. I don't know why it's not working, this one, but oh, okay. So still searching, I don't know what. The other fund will be real estate. When you are based in Dubai, of course, real estate is very important as an asset class. And this is the funds we will focus on. And the last one, it's Web3 and so Web3 with Web3 TV. We have the Web3 TV who is covering all the events in Dubai and even outside. We have a production city, a full studio, and this is the funds we are doing. So today I would like to focus on Coinvesting AI Fund. We have the first AI fund in the IFC, registered in the IFC, and we did it in collaboration with APTA. So you will meet Shiram from the APTA team. So APTA is a team of PhDs graduated in AI from Cambridge University. So they are based in Cambridge, and they will focus on the due diligence, tech due diligence on startup coming from Cambridge AI. So the PhDs graduated from Cambridge University. So they will do the due diligence on the AI aspect. So to be sure that the companies are real AI companies and not only tech companies. And when they will select the startups, then we will have in the IFC another investment committee and ethical committee. So the investment committee will focus on the business aspect of the startups to see if it's sellable, if it's scalable, if we can make money for the fund or not, and if it's interesting to go to market in the region. We have several incubators here in Dubai, so Innovation Hub, Hub 71 in Abu Dhabi. We are opening Saudi and India as an incubator because for us what is important is to bring into the region some startups and then to promote the startups locally. As you know, the region is investing a lot of money in AI, and this is really a strong position they are taking for the future in terms of development of the region and AI. So, Co-investing Capital, the AI VC fund will invest in startups coming from, is focusing on 3 verticals. So the first one will be, of course, the startups coming from Cambridge University. The second one will be to invest in startups coming from other university or globally worldwide. So the team will still do the due diligence on these foreign startups, and the investment committee will be exactly the same, of course, with the business investment committee and the ethical business committee. The second vertical will be to invest in some proprietary ideas. As I told you, Co-investing Group has a strong DNA in tech and fintech. So we have some ideas, we know the market, we know the financial market, so we will develop our own software with the team based in Cambridge and with all the experts we can approach in Cambridge and in other university. And so this is the three verticals. The fund will be what we call an exempt fund. So in the IFC, you have several categories of funds, so public, exempt, and QIF. Exempt fund means that the minimum investment will be 50,000 USD. So the fund itself would be a total of 100 million USD for the hard closing, and we will do a first soft closing at 50 million at the end of this year, because we want to really to start to do some investment. We have already started to do some investment, and Shirom will talk about in a few minutes about APTA and Hero, what we are doing, but we have other leads in the pipe, and this is what we want to promote. So the liquidity of the fund, it's a private equity VC fund, so it will be 7 years plus 1 plus 1. But as you know, in AI, the timeline is shorter than the normal private equity. So we think that we can start to distribute money to investors, let's say after 4 or 5 years. So the timeline is shorter than the private equity, which would be longer. So we will invest pre-seed, seed, and Series A, which is quite the first part of the investment. We will not go to Series B, C, or even D at this stage. So the fund will be audited, of course, by Grant Thornton, based in the IFC. We will have IQEQ as fund administrator, and I think this is almost what I have to say on the fund itself. So if you have questions, I'm always available, so feel free. And I think I will leave the floor to Shirom, who will talk about APTA and Hero, what we are doing. And I hope this one will work. This one's not working, I don't know why. So you have your laptop on, Shirom.
Hi, everyone. So today I want to talk about conversational AI. Conversational AI has really taken the world by storm, and it's the reason why we have such a large AI hype right now. So in particular, I want to talk about why large language models are so good, but also why they are so bad, and why there's a new paradigm out there to improve on this called agentic flow that we're building ourselves. I'm the CEO of APTA. We're a company based in Cambridge. All our founders have done our PhDs from the university, and we're very integrally linked with the forefront of AI research and trying to translate that over into the academic setting and in the business setting. So today I want to kind of cover 4 main things. Firstly, I want to explain to you what large language models are, what they're capable of, and how their abilities has rapidly evolved in the last few years. I then want to explain to you why those capabilities mean LLMs won't be the solution to everything, and why we need something called agentic flow. Thirdly, I want to explain why agentic flow in its current setting, which is a generalist setting, will fail to unlock the full value of the technology. And then finally, I'm going to explain how APTA is unlocking the potential of agentic flow for specific businesses through a bottom-up approach, and how we're already applying this in certain verticals. I'll talk about our partnership with Hero, which is applying this to the Web3 space. So a little bit of background to ourselves at APTA. Like I said, we think it's very important in order to excel in the AI space, to be very strongly linked with academia. A lot of the reason why this field is moving so quickly is because of some of the brightest minds in the world working on this. So in terms of the team at APTA, we all hold PhDs from the university. My co-founders, Adian, Vyas, and Vatsal, did their PhDs in the Machine Intelligence Lab. It's one of the most renowned institutions globally for cutting-edge AI research. Collectively as a team, we've published over 30 papers in top-tier conference journals and have over 1,000 citations around right now. In terms of my background, I worked on applied AI, specifically in the biotechnology sector, and then I joined McKinsey, where I was part of the early team doing Gen AI strategy consulting in collaboration with Quantum Black. So that's a bit about our academic background. And importantly, we've had the chance to experience this in the real-world setting as well, through a consultancy we founded before APTA, which is called Cambridge AI Studios. So essentially, we wanted to work with companies in the AI space and see what problems are they facing, and therefore which problems to go after for their own startup. So through this, we had the chance to work with a range of companies in the AI space. That involved working with some of the biggest AI native companies in the world. One of our lead clients was Savannah Systems. They are developing chips, hardware specifically for LLMs, and you'll definitely see them in the next few years emerging as a key competitor to NVIDIA. We also work with some of the biggest institutions of the world that are trying to adopt AI to unlock its potential, in particular the NHS in the UK and the Council of Health Insurance in Saudi Arabia. And finally, from the other side of the table, we worked with some investors in the space. Specifically, we worked with Dawn Capital. They're a large VC, specifically investing in SaaS, and they have a $700 million AI fund that we did technical due diligence for. And a lot of this technical DD we'll also be doing for the Coinvesting AI fund. So that's a little bit about our background. Let me now talk about the first thing on today's agenda, which was talking about what LLMs are, how they started, and where they are right now. So everything really kicked off in 2017 when Google published the Attention is All You Need paper, which essentially released the transformer architecture. And what this meant is we could now train models on a vastly greater amount of data. And the first researchers used this ability to train models on the huge amounts of text data that exist on the internet. And what they did is they basically took loads and loads of sentences from the internet, and they essentially masked the final word, and they trained these models to predict the next word. So we can see on this example here, they masked the final word, and then over time the models across millions and millions of sentences quickly got a good grasp of the English language to start with. So essentially the key thing I want to take away from this is the first models had a very good grasp of language, but unfortunately they didn't really take off. They were only really used in the research setting. And what really changed that was a new way of training these models developed by OpenAI, and that was called instruction fine-tuning. So in instruction fine-tuning, we use the baseline abilities of these models to have language ability, and then we further fine-tune them to do a whole range of tasks. So that could be summarizing paragraphs, translating paragraphs, writing poems, anything you can ask models like ChatGPT to do, that's what they train them on. So essentially what we do in this setting is you take an input and an output. So an input could be a large paragraph, and the output could be a designated or optimal summary. And you train these models on lots and lots of input-output pairs for various tasks. And then what emerges are models like ChatGPT, instruction fine-tuned models. These are models that don't only have a very good grasp of language, aka predicting the next word, but they can actually do useful tasks with that ability. And ever since, more and more companies have come out and developed more instruction fine-tuned models. These models are essentially trained on more data across the internet, or are fine-tuned to be better at doing specific tasks. So that's what LLMs are right now. And now I want to explain to you why LLMs aren't going to be this be-all and end-all. I think there's a lot of hype around LLMs. A lot of AI companies are trying to build everything around LLMs. But LLMs have kind of two main fundamental limitations. The first is LLMs are really only natively designed to handle text. That's it. But there's a huge amount of data in the world that exists in different forms. A lot of it exists in structured form. So that's tables, databases. Just think in companies how much of that data is stored in an Excel or an enterprise-grade database. They also don't handle numerical data, or charts and diagrams, or multimodal data. So a lot of research efforts happening right now to expand the capabilities of LLMs to handle these data types. But even if that problem is solved, there's a second much bigger problem. And that is that LLMs don't reason. They just predict the next word. And I think the best way to demonstrate this limitation is to give you an example. So if we use this question here, what is the weather today? On the surface, it seems like a pretty easy question, right? But even this question requires reasoning. So what an LLM will do is it will simply try and predict the next word. So words like carpet, glass, don't have a very high probability because LLMs know in language that doesn't often follow the sentence. But words like sunny, cloudy, snowy, windy have a much higher probability, and they may be selected at random. There's no actual ground truth or reasoning in how the LLM decides what word is selected next. So that's a big limitation of LLM's inability to reason, and it leads to inaccurate or not robust answers. And the field has kind of realized this problem and has proposed a new architecture, which is called agentic flow. So in agentic flow, we only use LLMs for what they're good at, which is their language ability. And we let the cognitive heavy lifting to be done by other models. Models which are deterministic, which means there's a fixed relationship between an input and output. It's not probabilistic. It's not stochastic. So let me give you an example of agentic flow in action. And this is exactly what we're doing at APTA. So let's take a question, what is the weather today? Now, what we do in agentic flow is we use the LLM as first of the ears of the system. So it takes a question in, and it tries to understand the intent of the user. What is the user trying to say? And this is, again, leveraging its language ability. It then breaks that question down into tasks. Okay, first I need to know what the location is of the user, and secondly I need to know what the live weather is in that respective location. And then that's it. The LLM doesn't do any more. It passes these tasks on to agentic functions. These are software engineering packages or machine learning models or deep learning models that are optimized for different types of data. It could be structured, it could be numerical, it could be text. And they're designed to be deterministic, but they're designed to reason. So in this use case, the first agent will try and find your location. Maybe it'll look at your IP address. And then the second agent will take that location and then read through a live database of weather. And you can see after step 4, agent 2 produces an answer. And it's the right answer, but it's not necessarily the most intuitive answer. So what we do in the final step of agentic flow is we pass the output back to an LLM that acts now as the mouth of the system, and it articulates the output in natural language. And what this means now, with agentic flow, you have the best of both worlds. You have the ability to speak to technology with natural language, which is the best way to interact with technology. It reduces all barriers to entry. But then simultaneously, you have the ability to reason and produce robust answers downstream of many different data types that LLMs can't handle. And excitingly, agentic flow has begun to be incorporated in some of the most widely used models in the world, specifically GPT-4o by OpenAI. So now I want to explain to you what that kind of offers in a generalist setting and why it's probably not enough for businesses. So, off-the-shelf models like GPT offer a suite of what I call surface-level agents. So this includes agents like the web search agent. So this now means that you can answer questions in a real-time, up-to-date fashion. I think GPT from the past, especially GPT 3.5, you'd often get a warning, I'm only trained up to December 2023 or November 2021. I can't answer questions after this point. And what the web search agent does is it enables you to kind of overcome that. Because instead of the LLM answering, the LLM now triggers the web search, and the web search tries to answer the question. Another agent is the Python code agent. That enables you to start doing maths, because like I said, LLMs can't handle numbers or do mathematical logic. You have a file upload agent, enabling you to read from files or image analysis. And these agents are great, but I think OpenAI and all these models are designed to cater to a broad set of use cases. So this is great. It's kind of tailored to pretty much any use case in the world. But what it compromises is depth. So they offer kind of very surface-level capabilities. But to kind of really excel in a business setting, you want to have deep capabilities. And there's 3 reasons why generalist agentic flow will never be able to provide that. So the first reason is these systems do not have specialized agents for particular niches. So let's take this example in the bottom right. Imagine you're at Morgan Stanley, you're part of the equity research team, and you want to tell your traders what stocks or what are the attributes of stocks that tend to perform well recently, so maybe in August 2024. Now, a web search agent, any of these agents, they can't answer that question. They're simply not designed to do so. This task is too niche, it's too specialized, and these surface-level agents will never be able to answer that question. So that's the first problem. We don't have specialized agents to do this task. You probably need some form of machine learning model which can extract feature importance from these stocks. So that's the first problem, a lack of specialized agents. And the second problem is, even if you did have these specialized agents available by OpenAI, you don't necessarily have the data streams powering them. So at the most, OpenAI is linked into web search. That's it. But to answer this type of question, you probably need all the information, the time series price information of stocks to know which stocks performed best in August. And you also need to know all the metadata, all the attributes of those stocks. Otherwise, there's no way you can calculate these attributes. So that's the second problem. And then the third problem is all these models operate reactively. So you type a question in and it generates the answer. And while that's okay for fairly simple questions which can be computed fairly quickly, it's very problematic for deeper questions that require more complex analytics. The user would have to simply wait too long and it's not compatible with user experience. So those are kind of the main problems with generalist agentic flow. Let me now explain how APTA is solving these problems. So the first way, from a conceptual level of how we kind of tackle this problem, is we do not try and be the jack of all trades, this horizontal model which applies in every use case. Instead, we focus bottom up, building in particular verticals, small niches. And what this means is you can truly understand what the main use cases are in that vertical and provide the depth needed to really add value. So specifically, once we understand the use cases in a vertical, we build specialized agents for that vertical. We then power those agents with the bespoke data streams they require. And then finally, in terms of technically, we shift the paradigm. We don't operate reactively. We preempt. We understand the use cases and we pre-compute complex intermediate steps so that when a user asks a very complex question that would otherwise take ages to load, we've already done a lot of the computationally heavy steps, meaning we can quickly deliver those final steps and produce answers relatively quickly. So that's what we do at APTA. APTA's architecture is completely industry agnostic. We can build in any sector. But currently, to start with, while the industry tries to catch up with agentic flow and actually truly understands the problem with LLMs, we build vertical-specific agents in partnerships with other companies. So I want to mention a partnership we have right now with Hero, one of Coinvesting Holdings' subsidiary companies, and that is essentially a co-pilot for the Web3 space. So right now, in Web3, information is scattered all over the place. There's no single unified source to get information easily, especially downstream of natural language questions. And then secondly is a bigger problem in terms of research analytics. Right now, research analytics is only really available to high net worth individuals. And we want to democratize this analytics to the everyday user, so everyone can make more informed decisions. And in the medium term, our goal is to become the perplexity search, the Google of Web3, the single landing point where users can come and navigate their journeys in the Web3 space. So this is our kind of technical architecture with bespoke agents specifically for the Web3 space and data streams powering these agents. And I'd like to give you a quick glimpse of this in action. So here, a user is trying to source some tokens that meet their particular investment thesis. They want to find gaming coins of a particular market cap, which have been near the bottom. They hit their all-time low in the last 2 months, and they haven't really increased very much more since. They haven't increased percent more since. So the LLM is understanding the intent of this question and passing this on to one of our experts, the live market expert. And now we're adding those 4 steps of reasoning in and quickly filtering that data to provide you these insights quickly. You can imagine an LLM is not capable of doing this. 1, because it can't handle structured databases, and 2, because it can't do this multi-step reasoning. And now the user is asking for some more advanced insights downstream of this data. I think this really highlights the preemptive nature of our output. And you can see we've already pre-computed a lot of the technical indicators. And quickly to provide an answer, we just put these in context, combine them together, and give the user an overall idea of what the technical indicators are suggesting about this token. And here you can see the UI is fully multimodal, so you have graphs and full outputs. So that's kind of an example of what we're already capable of with Hero, something we've only been building for the last 3.5 months. And now I want to give you a demonstration of some of the features we're trying to build and release shortly. So right now, in crypto, there are a lot of influencers, KOLs, that drive the market. And we want to make sure that people have full transparency when they listen to an influencer. So they could now ask, influencer X has told me to buy this token. What's that track record? And our system can tell you the percentage of times their track record, they make good calls or bad calls. But maybe even more nuanced insights. How often or how long after the influencer has suggested a token does the price go up for before crashing? There's a lot of influencers who do pump and dump schemes. So that's kind of one example. And then a second thing that we're working on right now is automated execution. So this enables users to ask us to buy particular tokens under specific criteria, and then enable us to essentially execute these transactions under these sets of rules. And again, because we have multi-step reasoning, we have logic, we're able to execute these trades rapidly on the fly without you having to be involved in the loop. So yeah, that's an example of our kind of system in action. If you're interested in using the product, we're getting early access. Feel free to scan the QR code on the slides. And yeah, thank you very much for listening. Happy to take any questions.
Does anyone have questions like this particular topic?
So we should need to build the base model as well.
So there's kind of like two types of models here, right? So you've got the base LLM. Okay, so the base LLM is honestly, it's just the orchestrator of the agents, right? So we're just using the LLM for its language ability, not its ability to do particular tasks, right? So we are actually very agnostic to the LLM we use. Right now we use Llama 3.1, but in the past we've used other models. We essentially keep switching to the cheaper model that maintains the same ability to understand language. And now for most LLMs, language ability is pretty simple. So for us, the LLM is honestly a small piece of the puzzle, and it's not the most technically complex. The technicality for us is what agents to build, and also how to coordinate those agents. When there's a particular natural language question, you want to make sure you activate the right agents, but also in the right order. For example, in that weather question I gave you, there is no point of using that database reader agent first if you don't know what the location of the user is before that. That's kind of some of the complexity in the space that we focus on. The LLM we have, and it's very, very agnostic. You could easily switch, whatever.
So in that case, given other comments for already also switching the page up to more models. It looks like we should read that it's kind of the data supplied to the agents, which come out either the third that of the willing agent as well.
Yeah, I think definitely the industry is going to move towards agentic flow. The people who are going to win are people who solve this orchestration layer. How can I orchestrate the right agents downstream of natural language response? Companies who can do that very well are going to win. The latency is also another very big problem. So if you've used agentic workflows, especially in LangChain right now, they're very slow. So being able to deliver those workflows very quickly is going to be another thing. And then finally, I think companies like OpenAI will move to agentic. They've already done that with GPT-4, but recently they've kind of shifted to another way of reasoning, the chain of thought. But regardless, I think they're going to start offering agents which have wide usability. But like I mentioned before, the problem with that is those agents don't necessarily offer deep functions. So for example, if I'm in the Web3 space and I'm going to search the blockchain, what agent will I use? I think agents like a natural language to database reader will be widely applicable to many use cases. But other agents will be very specific, and those companies that can build those specific agents for particular use cases will win. So it's all about taking the foundational models, it could be foundational agentic flow, and then adding those additional agents that can help you in that space as well. But right now we're still looking for, APTA's trying to, also build in this space, but we've already kind of importantly solved this orchestration layer and also the latency layer. So companies like that who can add those features in as well as a base set of agents will win. But it'd be interesting to see how that will work in action future.
Cool. And one of those questions, so how many of you guys get in the trade from the last slide?
Yeah. So it's essentially the LLM will take the question in, understand exactly the criteria in natural language what you're trying to do. This will then get passed to a particular agent called a market execute agent, right? Essentially what that is it breaks down the exact steps that are required. And then you can plug in to a particular solver that can then execute those trades. So we've seen Llama swap as an example. When you meet a particular criteria, it triggers an APTA call to a solver that then executes a trade via a smart contract. So we've already kind of seen we've already seen...
So as a user, I would look to pass my
wallet
address and the password through that agent.
So there are ways of doing it without sharing the password with us, right? So you can already use solvers to connect with your wallet and then execute trades. I think right now the key step is you always have full authorization over any transaction you make, right? You click, there's a swap and you click authorize. And we need to work to a step where initially the user will be involved in the loop, and then ideally, hopefully, when we get to a step, they can fully be hands-off. So in the initial version, the one that we're working on right now with a company called Interface in Cambridge is how I can take a natural language question and then create the correct API call to their solver. And then they can still click execute. Downstream, hopefully, with enough guardrails in place, they can be out of the loop. But the key thing to stress is the actual execution of trades is fairly simple. It's just ensuring that they're timed correctly, which can be done. For example, that was like when Bitcoin hit 63,000. It's very easy to find out what the price is of Bitcoin through the live market expert. When a rule is triggered, then it triggers the API call to the solver that will execute the trade, as an example.
So maybe one question. So does it mean that an agent will need to be running constantly in the background?
Yeah.
To do the pay for the API calls?
Yeah, so agents are, they don't have to always be running in the background. Some of our agents are continuously in the background, right? Because imagine our live market expert. The prices of tokens are changing every second. So that needs to be continuously running to be continuously updated, right? Because it's pulling live market information from all the centralized exchanges and decentralized exchanges. If you're trying to make a transaction, that API doesn't have to be active all the time. It just needs to be triggered at the right time. And then you can make that call. But the user wouldn't be charged, or we're in charge of the inference. The user would probably pay a transaction fee.
Yeah, so we have just heard from Sharon from APTA more about our product, Hero AI Search. So first of all, a few words about Hero. Just like APTA AI, Hero is a part of the group of companies that are supported by Coinvesting Capital, and these companies are also collaborating with each other. And with Hero, we have a joint venture with APTA AI to bring the AI search to the market, but also an ecosystem of products. So, of course, the AI search and AI Copilot is the most innovative part of our product. It is a flagship product that is still in the beta stage, and we are launching at the end of the year. However, we have built a whole suite of products, a whole ecosystem to be used alongside the AI search. So with this presentation, my name is Ada Göndeş. I'm head of business development and investor relations at Hero. So here I'm just going to quickly go through the parts. Just to give a little bit of background on how we are operating as an ecosystem and what benefits our users have from that. So first of all, Hero Browser is a private browser. If you're in Web3 for longer, you probably know Brave. It's completely anonymous, secure browser. It's not traffic. It is not tracking users' activities online, and this is very relevant for many people in Web3, but not only. We are in the stage where we're seeking more independence from the governments, from big data-driven companies that are utilizing this users' data to monetize it. We want to give the power back into the hands of our users. So Hero Browser is part of this. And this product is live. It's possible to download it already on our website. It has AI search integrated into the product, and also a self-servicing ad network. So we know that it's quite complicated to advertise anything crypto related, because big providers like Google, Facebook, X are quite often limiting this advertising because of their internal policies. With Hero AI Search, for example, we looked at some example that Sharon showed before, a user looking for a coin to buy, We receive a list of exchanges where this coin is listed. So that is, for example, one of the use cases where crypto service providers can advertise the product. Now, the other product is Hero Wallet. It's a non-custodial wallet, just like MetaMask, Trust Wallet. Maybe you're using some of them. It has a multi-chain support, NFT display, and some cool features that we're gonna have soon, like recurring payments if you're subscribed to some kind of services with crypto and want to do that on a monthly basis from your wallet. And this is how the wallet looks like. It's also in our browser, and it's possible to use it as a standalone product, of course, as well. Then Hero Market is a product that looks like CoinMarketCap. We have not only coins there, we also have metals, we will have stocks there as well. So for anyone who is in crypto, Web3, wants to get constant market updates through this tool, it's possible to have it. It also goes together with a private wallet that we already launched. And then HeroPay is a B2B product. It's a company that we acquired this summer. It has a virtual asset service provider license in EU, in Lithuania. And this product, it's a B2B product. It helps businesses to accept payments in crypto. It supports a variety of currencies, and the beauty of it is that in 38 countries, those businesses can receive deposits directly to their fiat account. So we know that many small businesses might be interested in accepting payments in crypto. However, it's very difficult while still in the non-crypto world to then have it actually on your own bank account to do the transactions needed to pay for usual services. So we offer that with HeroPay. And then finally, the single ID for all Hero products is a solution that anyone can have on their wallet, on their private wallet. They only need to KYC once to have that ID verified, and then with the same wallet, with the same ID, the user can use anything online, discover new dApps, utilize their favorite dApps as well, and there's no need to re-KYC, and this is all connected with the browser as well, and with a search solution. So all of these products, they can be utilized as standalone products, but we believe that the beauty of it is, and the UX of someone truly crypto native is when the products are utilized together. And of course, with the tightening regulations all around the world, we know that very soon it's going to be really obligatory to have the wallet KYC for any interactions online, just because the regulators are asking for that. So it comes in very handy for anyone who still wants this privacy and security of a non-custodial wallet, but needs to comply with the regulations for anything they do online. So this is a short overview of what we do at Hero and how we're collaborating with APTA and integrating the AI product in our services. So thank you for this.